In this video, I want to take a look at another approach for finding the least squares regression line from a set of data similar to the one that we looked at back in Chapter 4. So this is the exact same example that we did where we've got the reading scores and math scores from a number of states in the US. You may remember this example. And we were asked to compute the correlation coefficient, compute the least squares regression line, and predict the math proficiency in New Mexico, given that reading proficiency in New Mexico is 65%. And we did all of this already in Excel. In fact, here are some remnants of the calculations we did. I found the correlation coefficient right here. Here's R, and if you highlight the function that we used, you can see up here the command for that was correl for correlation, and it spits out the correlation coefficient. So you do equals correl, and then you put the known y values, comma, the known x values. So you get those values in that particular manner. To find the least squares regression line, we went through a process that involved this chart here, where we actually did a scatter plot. In your in the spreadsheet that you'll have access to during exams in the Respondus lockdown browser, they don't have nearly as much chart functionality, so they can't necessarily do these graphs. So I want to show you an alternative way to get this equation for the least squares regression line in Excel just using a command here. So I'm going to move this graph over to the side a little bit, and I'm going to do the equation for the least squares regression line here. So LSRL for least squares regression line. And what I'm trying to do is reproduce this equation. So I'm going to do that here. I'm going to do the equal sign, and the function that I'm doing is called line estimate, or linear estimate. So I'm going to start typing LIN, and you'll see linest is the function that we're going for. So I want that linest function, and it asks for us to then put the known y values, comma, the known x values, and then it has these two other things. We can leave those ones blank. So I'm going to do the known y values. Coming back to my problem over here, I was calling the math scores the y values. So that's what I want to enter first. I want to enter where I put the math scores. So that's this list of values right here. So if I highlight them, it will populate the function with that particular array of values. And then we're supposed to put in the known x values. And I've got those right here. So I will highlight those, and those will get plugged in. And we have the option of these two additional pieces. We don't need to worry about them. We can just close our parentheses, and it will give us what we're looking for. So linest, the y values, comma, the x values, and hit enter. And what it'll do is it'll spit out two separate values. And these two values correspond to the a and the b, to the slope and the y-intercept. So the one right here is the slope, and the one right here is the y-intercept. It'll spit out the slope, comma, the y-intercept. And you can compare them to the value up here to make sure that they are, in fact, the same thing. So the slope is 0.822621. We're getting even more decimals than this gave us, 0.8226. And then the y-intercept is 11.036. This one, again, gives us even more decimals, 11.03585. So this way, by using the linest command, the linest function, we don't need to create a scatter plot. And we can skip that portion, which, again, on the exam, this built-in, the charting functionality, the graphing functionality, there's not nearly as much of that built into that spreadsheet. So this is the command you'll need to use. Again, it's linear estimate, LINEST, and you can use that to find your least squares regression line. You can still use correlation if you're trying to find R, and incidentally, if you want R squared and you don't want to just square that value, oops, type right here, I just do. Of course, I overwrote a bunch of stuff. Let me just fill this back out again real quickly. I apologize. Okay, there's those values back. Didn't mean to screw that up. I just want to type in something else. If I want R squared, it spit out the r-squared value on that graph. I can get it by simply squaring this value right here, or alternatively, I can do equals RSQ, which stands for r squared, and it'll give me the same thing that I'm looking for. So RSQ, it'll ask for the known y's, I can plug those in, comma the known x's, plug those in, and hit enter. And sure enough, it's going to give me the same r squared value that the graph gave us over here. Alternatively, you don't need this RSQ command. You can also just take this number and square it. So we can compare that here. If I just simply take this number, 0.808623, and I square it, raise it to the second power, and hit enter, it will give me the same number. You'll notice it's off in the 6th decimal place, but that's more than enough accuracy for us. So again, the point of this video is not to make you go back and redo everything you've done. It's just to highlight the fact that on the actual exam, using a scatter plot like this may not be a real option. And so what you'll want to do instead, if you need to compute a least squares regression line, is to use the linest command, the linest function. So give that some practice before the exam, and hopefully it won't cause you too much trouble that there's 2 ways to do it.